where we stopped last time. And where we stopped last time, we were able to see how resistors are connected in series. And today, by God's grace, we'll be seeing how resistors are connected in parallel. So, before we continue, let me show you sample of resistors. These ones are the resistors we are talking about. This is a standard resistor. This one is also a standard resistor of 1 ohms. And this is another form of resistor, and this one is called resistance box, which has different values of resistors. We have 1, we have 2, we have 3, we have 4. So when you combine 1 and 2, it gives you 3. 2 and 2 will give you 4. So if you want to add 1 ohm resistor, that means you are going to move the key of this. And this too is another form of a resistor, but this one is called a variable resistor, and it's called a rheostat. Is that okay? So now let's continue from where we stopped. As I say, this is how a circuit is connected in parallel. You see, last time when we look at series connection, can you see the difference now? This one side by side, but for series, the resistors are connected end to end. This way, end to end. This is series connection, while this one is parallel because side by side. So, if we have resistor of this kind, we can now say, okay, let this one be R1, this one R2, this one R3. And let's also add voltage source on the resistors. So this way. So we have V here. And the current, we say this is positive, the longer side, and this one is negative, the shorter side. And the current I here. So the current that flows, this current here from the source flows, we're reaching this point here, it now divides. And part of it goes this way, part of it goes this way, and part of it goes this way. So here we can say I1, here we can say I2, here we can say I3. So as the current is moving again, coming to this side, they now converge again. And that is how the cycle continues. Is that okay? So now, but the voltage across voltage drop across each of these resistors connected in parallel is the same. So that means V1 here is equal to V2 here and is equal to V3 here under parallel connection. But in series we say that we have the same current flowing and the voltages drop are different, but in parallel connection the voltages drop is the same. You get the difference now. Is that okay? Thank you. So, since that should be the case now, we say current, a single current flow, that is I, is equal to the summation of currents flowing, I1 plus I2 plus I3. That is for parallel. But for series, the current flow is the same all through. Then in this side now, we say voltage across each of the resistors in parallel is the same. So we have V is equal to V1 equal to V2 equal to V3. Is that okay? I hope we are together. So now, from Ohm's law, which very soon we will now state it and see it better. From Ohm's law, we say that V is equal to IR. V is equal to IR. Therefore, we say V is all the same, true? So we have I is equal to V over what? R from this formula here. But substituting, okay, let me call this one equation 1. Let me call this one equation 2. Substituting the value of I in equation 1 now. We have I, which is, first I, which is V over R, now is equal to, the next one now is we have I1, and we say that voltages are what? The same all through. So we can now take the first one, which is what? V over R1. Then next one is I2 plus V over R2. Next one is I3. Say V over R3. But you see something here? Yes. V is common all through here. So we have V over R is equal to V. We take it out as a common. 1 over R1 plus 1 over R2 plus 1 over R3. So this one is over 1. So by seeing, we can do what we call cross division. This and this are from the equal sign. We can cancel this one, cancel this one. So we remain with 1 over R equal to 1 over R1 plus 1 over R2 plus 1 over R3. So this is the formula when resistors are connected in parallel. This is a combination. Is that okay? But other way around, in other way around, if you have two resistors connected in parallel, like this, this one is parallel connection. So this one is different from having something like this. I hope you get it. This is different from having something like this. This is series connection because this one is the same wire end to end, but this one different wire combined. Is that okay? So if we have R1 here, R2 here, then we now have R is equal to 1 over R, 1 plus 1 over R2, depending on number of resistors you have. But having this one, the LCM here is what? R1, R1, R2. Can we take it to this side now? But you know we can cross multiply this to this, this to this. So we have R1, R2 equal to R into R1 plus R2. Want to make R the subject of formula. So making R the subject of formula, here we divide both sides by R1 plus R2, R1 plus R2. Therefore, a combined resistance for two resistors in parallel is given by this formula R1, R2 over R1 plus R2. So if you want to solve question having two resistors, this is the formula you use. But that one is not applied to when we have more than two resistors. If you have more than two resistors, you use the other formula R1 plus R2 depending on number of resistors you have.